So, hello, this is Heron. So I'll give you a small update. There's not much finished yet. I had problems with my printer, and now I managed to kind of print a usable pattern for the mold for the zinc casting experiment. Also did some other stuff. I kind of put together the next temporary version of the bicycle sound system, at least the power part, and I made this USB powered lamp for this workspace here. I can just plug it in, and you can see it's powered up now. It's kind of fiddly to do it with one hand, but otherwise it works. Gives a little light. I also had to make a new tip for my soldering iron to repair the printer, and a lot of footage in the camera. I think I will just try to throw it together and make some kind of sense out of it, and call it an update video. So now you will see the problems with the printer and the basically the plans for this thing. And another bad thing, I just tried to print some parts, or printed some, and it chipped the glass, so I have to get some glass, put it on there. Well, it's the next day. I have to replace the glass on my printer. I've already removed the one that was on it. I think I have to clean it up with a little brake cleaner or something. And I have this double-sided tape for heat sinks. Should work fine. And relatively thin glass. I think it was from some kind of picture frame or something. And I will just put some kind of weak spot in there with this glass cutter, and then you can break it. So so I managed to cut a fitting glass piece. It's not perfect. It has some kind of imperfect edges, but it will do the job. I mean, I will break it anyway sometime, and then I have to replace it. So I cleaned up the bed with some brake cleaner. Works fine. And I'll apply those stripes. I will leave 1 millimeter between them to make sure that it's flat. If they overlap, it will not be flat anymore. So leave a small gap between those stripes, otherwise it wouldn't work. But just like that, one beneath the other, and a small gap so that they don't overlap. Well, this is how it looks like with the tape on. I have to peel the protective stuff and put the glass on, level the printer. So I've added the glass, and I'm now heating it up to 80 C, or maybe 85. I think I will heat it up as high as possible, because this heatsink tape will soften, and it will just slowly set, and all the air will come out. You can see the darker areas where it's contacted the stuff, and the lighter areas where there's still some air. And this will disappear over time, just due to the material being softer when it's heated and slowly sinking in and driving the air out. So that's no problem. I had that before, and it will just, I mean, you could press it to get it on. Oh, it's hot. but then you probably deform it or break the glass. It's only 2 millimeters, so this works fine for me. I mean, it gets hot, and that's all you need. So I was just trying to level it, but unfortunately the glass is too thin. I cannot get deep enough, so I have to put some nuts under the springs to get a little extension. I just put some nuts under the springs to give me the little extra that I need. I'll clean that up a little bit. I install that. Didn't turn out that good, but it feels sharper now. And I just got around there with some small flat file and sharpened that angle that grips when it feeds. So maybe that is enough. I can start printing some parts. I have to print a pattern for that experiment with the zinc casting. So I thought it would be easy, just print a pattern. Takes a day, but if your printer doesn't work, that's the problem. So first I broke the glass, and then it turns out that the feed mechanism, yeah. I think My Fault Boy did something about his printer too. Those JG Aurora things, they're nice in from some aspect, because they're a nice rigid sheet metal construction. They have covered feed screws and things like that, but they're not totally finished, and there's a good base if you want to tinker around. If you just want a printer that works, go for something else. But if you want to tinker around, the design and the solid construction will, I think it will be a nicer printer if you really fine tune it to the last point. But then it's also 3-year-old. It's not really up to date. But I like the concept of having a real sheet metal construction design and not just some extruded stuff put together in some skeleton printer. So this is the material I want to use. I have those zinc ingots, some aluminium, some copper. I have this magnesium band. Don't have to put much in it. So this is the stuff I will try to make the zinc alloy out of. And now you will see the bicycle system. This is the where I put this circuit from this bicycle forum. That is, yeah, literally called forums loader. Yeah, and I will see that. So hello, I thought I'd give you a small update on the bicycle stereo system. Planning to make a new control unit, and I've ordered some advanced charger circuit for the dynamo. This is the thing, and hopefully I can get nearly double the power out of that hub dynamo thing with that. It can also be used as a solar charger. So I will have a switch that switches the input from the dynamo to a socket where I can plug in a small solar panel. And I will also have a 4-pole switch that can switch between this internal battery and a bigger external battery that I can remove, so that I can charge a battery for other purposes. And I thought it would also be nice to put one of those small analog amp meters in there, plus and minus basically, to give you an indicator of whether you consume energy or produce energy, basically. Your net current going into the battery. And I have those small latching switches. They stay, so it's on, off, and I have a plastic ring here, and they give blue light. So this is the plan for the setup. This will be the switching between dynamo and solar. This will be internal external battery, the in-out amp thing here, that will be a small digital voltmeter that I can switch on and off with this button here, and the amp, the camera, and one switch that switches on and off the light for the buttons, and some backlighting for the amp meter. And that's basically it. So I tinkered around a little bit here in Fusion. This is just the web app on a crappy laptop, and I made this part, or designed this part. It's basically a shell, well, whatever. Rotate it a little bit. You see it's choppy as hell. There's a slot in the front for the camera. This is for this Sony action cam. A hole in the bottom for a screw to fix it. Some slits to get some air in that thing. And fixture to fix it to the to a part of the handle, to that bar that connects the handle to the rest of the bicycle, basically. Same technique as with the player. Some holes for cable ties, and I will put some rubber under that. And in the front is this thing, which is basically well, this setup here I came up with before, and yeah, a lot of switches and things like that, so that I can switch the input, switch to an external battery, monitor the amperage and the voltage, and switch the amp, the cam, and the backlight here for the switches and for the amp meter. So I've printed the front, inserted one of the four button switches. They're kind of latching switches. They're not buttons. They stay in the engaged position. I'll put this amp meter behind it. Should have printed a recess. It's a kind of deep, but it's a prototype anyway. Put some small digital voltmeter in there, and two switches to switch the input and the battery output, basically, so that I can switch from the internal small battery to a bigger external that I can use for other stuff. I have basically a big external battery that I can charge with the bicycle. I can also use this thing as a solar charger, so the input switch will be between a dynamo and some kind of plug where I can put in a solar panel, so that I can use this thing as an energy source when I'm not riding my bicycle. Then another thing that I want to show you is this small buck converter. And yeah, the charging circuit is already has a 5-volt output. But the thing is, with most electronic devices, internally they run on 3.8 volts batteries, or 3.7 or something. So if you plug them, or if you power them via USB, you throw away a lot of energy. And there's, as far as I can tell, I mean, I didn't take it apart, but there's a linear voltage regulator in there that pulls it down to 3.8 or 3.3 or something. And I could reduce the power consumption of this camera when powered over USB significantly when I use a separate buck converter and go directly from the unquote 12 volts protected direct battery access here and go down to 3.8. This will reduce the power consumption on nearly 50%. So in combination with the more efficient charging unit, I should be able to run the music system and the camera without much effort. So I mean, I was able to run the camera and music if the music wasn't too loud before with the undervolting thing, but I will see how much extra power I get out of the new charger. And yeah. Oh, this is Harold again. Sorry for the recent lack of video, but kinda busy assembling this thing here. This is the next version of the main unit of the bicycle system. I decided to put a amp meter in there, classic one, to show you whether you charge or discharge the battery, then a voltmeter. Here you can see the whole setup. I'll put that all in and try to yeah, just fit it in there. I don't have the soft thick double-sided tape, so I just use the thin one and kind of crumble it together. I mean, I will not glue this thing closed yet. I will just close it up with some tape for the test. So yeah. Another small thing why I used that loader or that circuit. I was thinking about doing that myself, but it's really hard to find data on the hub dynamo. So I would have to build a test stand and measure the behavior of that dynamo over certain rotational speeds, and then program a microcontroller and then do all the compensation and all that kind of stuff. And if nothing goes wrong, it would take me a few months just to do that. It's kind of hard to find that thing. It's hobby project from a bicycle forum. What it's called has this kind of stupid name of Forumslader, for forums loader. Yeah, they clearly don't have a marketing department for choosing names. But anyway, it was not that cheap. I mean, they have to source all the materials, put it together, get the PCB made, and then all the labor of testing and putting together. But yeah, so this is just a better option, and I couldn't do much better. It would take me a lot of time. So This is basically a maximum power point tracking with some compensation for the inductance of the motor, and it basically sucks the last drop of juice out of that poor dynamo. And yeah, so quite a messy setup here. I'm attaching everything. This is connect all the connections for the 5 volts. I have a small buck converter for the camera, for that undervolting thing to save a little bit of energy. Then I have a regular 12 volt, one cable that is not used yet. It will be for the backlight. I'm not connect the backlight yet. So yeah, put that all together and put it on a bicycle and have a test run in the next hour, I think. So now I will have to basically throw this whole thing together and connect the 12 volt thing with a switch for the amp. There's another temporarily assembled thing, and 2 wires dangling out here. One is USB, the other is 12 volt for the amp. Here's the dynamo input and a wire for a potential external battery. And I put all this thing together. The camera is mounted, and we'll have to attach it to the bicycle to test it. And the weather is quite nice, so I think I will get out, get some fresh air and test this thing. Seems to work now with a bolt with the small nuts as a spacer. So I'll wait for that to print, and then I will do another test with the bicycle system. Just ride it a little bit and see how much I get. I did it yesterday, and I get away from this thing, and I was surprised. It's something between 5 and 6 watts, I think I can get out of it, and with just the buck converter it was more like 3. So now I can turn the music up a little higher and still run an action cam, and also charge the battery, so I still have some excess energy that I can use for charging a cell phone or whatever. So I'm really happy with that. Makes me questioning why there isn't a usable system like that for bicycles commercially available, because it's really usable and it works, and especially when you do longer tours or so, it be quite beneficial to have some independent energy source. And you don't really notice that it's braking or so. I mean, technically, yeah, you have to pedal a little harder, 6 watts harder, or 6.5, because it's quite efficient and you have a little loss. But yeah, now wait for that to print. We'll reassemble that thing and do another ride. I also made a mistake with the design. The angle where it's mounted to the bicycle I for some reason halved, so now I have to put to rebuild that angle with some gasket rubber and some super glue, but it works fine, and it's a prototype anyway. So I had some problems with the screw. First I printed the thumb screw for the camera, and then it broke. And I tried to print part with some internal thread to put a piece of a screw in there, or that small bolt. It was the only 1/4 inch coarse thread that I had. It's a little short. I think I will order a threaded rod that goes all the way through, and just put a small threaded hole in there, a printed hole, and just leave the threaded rod that length. That should work better, but now I managed to super glue it on, and it seems to work. So I will order a threaded rod and just use that. By the way, I used one of those, and it's one of those thick and kind of flexible super glues that stay flexible even when they get hard. So I wouldn't use the pure, unrefined, cheap stuff, because it gets extremely hard and brittle when it solidifies. But this stuff stays flexible, so it will not break when there's some shock to it. And here I am again, and now I will cut in a little bit from the making of that lamp. Also a little thing on the bicycle thing. When I'm finished doing the speakers and all that kind of stuff, I can also do a last optimizing with this small DSP circuit to get the last, to fine tune the last bit of sound quality out of that. So now you will see that lamp. So I made the next version. This is now printed in one piece, and hopefully it will not break. This one broke. I mean, it was a stupid idea to think that super glue would last in the long term. Other than that, the thin printed cover for the diffuser works fine. So I'll just print the cover now. This is glued in. I will do some connections here, solder some stuff, and back in a minute. I'll glue the stripes in, or the strips or whatever, and you can pretty much connect them wherever you want. There's a 24, and this will connect to the other 24, and so just I just connected the ground here in the middle, and they're all lit up. So, by the way, this is undervolted, so normally it would look kind of like this if it would go at its rated voltage, but I will undervolt it anyway to something between 16 and 18 volts. Just wanted to spread out the light a little bit. I don't like point sources, especially when I work, so and this will be a replacement of this thing that broke off, and the stand will be the same. Now I'll show you the how I made this, the replacement tip for my soldering iron. Also, this is not really a complicated thing, and normally I wouldn't show that, but I wanted to test the camera holder. I made a camera holder. I don't have footage of that, but it's basically some scrap metal put together with a rubber sheet on it and a screw that holds the camera to it. And yeah, you will now see the first late footage with that camera holder. So just wanted to solder something, but this is how the iron looks, so I have to make a new tip. I will try to machine a replacement tip out of aluminium bronze. I mean, this seems to be some kind of copper core, with some nickel plating or so on it, or with some stainless sleeve or so. The ring seems to be steel, so it's some kind of composite stuff. And the tip also seems to be have some thicker steel case and a copper core or something like that. Ideally, I would make something out of copper or the titanium copper stuff or something, and nickel plate it. But we'll just make it out of the aluminium bronze and see how long it lasts. Will not last long. It will dissolve over time into the solder and get eaten away. But yeah, we'll see. This will be also a kind of test whether this camera holder will work for the lathe. So we will see about that. So this is the first test with the camera holder for the lathe. I have that is a spur basically. I cleaned it up a little bit from the experiment where I cast in the carbide cutting insert. It's silver containing mixed bronze stuff. There's one small inclusion here, but shouldn't matter. So the overall plan would be, if I could find that part out here, is to basically get this one, which is the old tip from the soldering iron, made out of this one. So I will basically turn it down to the major diameter here, and then cut from both sides, and we'll leave a little more on the tip to be able to file it down when it dissolves into the solder, because this is not really the right material, but will work for a time. So put my glasses on. I mean, you can skip a lot of safety rules, but protect your eyes. I basically work from both sides and be careful at the end. Don't think that I have to support it. This is quite rigid material and relatively easy to cut. I will have to hand crank all the time. Small lathe. I will go like that for convenience. At the end I will try to get a consistent feed, but now it doesn't matter, I'm just taking away material. The wheels are just so small, I cannot really feed consistently with just one hand. This is where it also works. I really have to get into the project of Cloud 42 with an automatic lead screw. It would be ideal because I don't have a quick change gearbox. Also not really a power feed other than the normal lead screw, so this solves both problems. the hand wheels, wow, it really gets into the hand, and maybe I have to put some improvised automatic feed there for a cordless drill. That may work. So we'll have the depth of cut now. It's kind of tedious with that small thing, especially with a lot of coffee. But yeah, we'll see. Well, now I'll go half the depth. Now I can feed by hand. Still a little inconsistent. Normally I wouldn't cut such a thin piece out of that thick bar stock or so, but this is a scrap piece anyway. It is what I have. Another quarter turn. Also with that stuff, I should be careful because, oh yeah, it's getting hot now. If you don't use cutting oil, and with those bronze you don't really need it, or with this bronze, you don't notice that the part gets quite toasty. I mean, theoretically it's not that much of a problem. The dimensions of the part are not critical, and it's carbide, and yeah. But I don't want to burn my fingers, so at least for that I have to at least keep in mind that it can get hot. So for now, I'm not really sure. I think I have to put a center drill in there. Just to be sure, I mean. Could get around with light cuts. This is 2 to 3 times as tough as brass, I would say. But yeah, maybe I try it. Maybe I just go for some light cuts. So the diameter of that thick piece here is about 7.5. And this is now about a little over 9. So I'll take a little bit off and then turn it around, turn the other half of the piece down, and see whether I can form a kind of soldering iron tip out of that. Hoping that there's no intrusion in the center of that thing, mess up the whole part, but then this is what you get when you work with casting scrap. starts getting a little scary with that big overhang. That should do the job. 7.5, good enough. Not even looking at the vernier. I'll do the same thing to that side. It's quite a challenge for the material if you think about it. It's only that thin stuff to grip on. Look how nice the chuck is. I love that chuck. It wasn't expensive. It's a nice rim chuck. It was worth the money because it's, for any hobby purpose, it centers. You can repeatedly put stuff in there and it's good enough. I mean, for really high precision, I wouldn't use a 3-jaw chuck anyway, but it saves a lot of time when you're doing home stuff. Smell the high phosphorus. Yeah. There's some bad stuff in there. I bet I can get the shape of that tip out of there. There's some stuff in there. Hoping that those bad spots disappear if I cut deeper, or at least that they turn out to be not that bad. After all, it was more like a test for the camera mount, and I also need a new chip mount. And it's at the end. Yeah, a lot of tweaking with that overhang. I'll get better. You can see still a little bit thicker on that side, but it doesn't really matter. So I would just cool it by holding it in my hand a little bit. Your body is quite good in regulating temperature. And pumping the excess heat out of your hands. So holding it a little bit would cool it down much quicker than could. So now I think I'll put it back in this way. Now I have to turn down some part. down to about 5 millimeters. Okay. I think I will do about 20 millimeters. So something like that. Yeah, something. I mean, it's not that critical. I'm just eyeballing it. When I cut from the other side, I make sure that the where do I have it? That the that thickness here is the right size, and it's also not critical. So all of those dimensions are probably plus minus 0.5 millimeters. So, as I said, it's more like a test for this camera mount. And I think I will have to change the lighting situation a little bit. It's not ideal, but it's about 5. Is it? That's about 6, not 5. Yeah, have to go one down. The further in I go, the less cheddar I get, as expected. That looks good. I mean, it's 4.9, 4.95, if I remember to read that vernier right. More than enough. So I'll now turn that around, and then it gets kind of scary, but I will try to seat that against the jaws as tight as possible so I get some support from that surface here. And to be honest, I will put a center in there. That's just too much. I will not just put a center in there. Oh, sorry, I'm bumping the camera a little bit. I'll make sure that the tapered surface is cutting a little bit. And that's enough. Now I can put a life center in there and support that thing. Got a little too scary with that large hangover or stick off or whatever. I don't know. You know what I mean. let's establish a unquote 4mm line there. Just taking the same and eyeballing it. Yeah, should a little more. That's good. Okay. I think this is close to 5. Don't want to overshoot it. Sorry, bumped the camera again. With the good calipers, you cannot hear them, or only a little bit. And also, if you tighten up that thumb screw a little bit, they lock. You don't need much. With the cheap ones, they are scratchy, and you need to tighten up the stuff, the thumb screw really hard to get them locked. So we'll just get a little bit of force on there, and now it stays. Put it over there, close it up, pull it out, and I get a measurement. Do it again just to make sure. And it's about 5.65. So I have to go a little deeper. I think I will make it a little, change that angle a little bit. Go more for a 90 on that edge. That should be good. Let's see, is that enough? Well, that was about it. Not bump it against that. I mean, pretty sure it didn't do much damage, but oh, 5. So now change the tool. I have a right-handed tool of the same set, so you don't have to adjust anything. Just make sure that there's no chip under there. Something like that. The spring pass. That looks good. do the job. I can get rid of the tailstock. Turn it around and cut some kind of taper, but first I will hacksaw that off. Another part just to make sure that it kind of works, and you can see that this is kind of the size. And I'll cut that thing off, put it around like that, and cut a taper in there, and then I can fit it in the soldering iron and test. So I've cut off the end with a hacksaw. I will try to fit it in here. It should fit. Yeah. So that the ring is inside the jaw and it clamps on the outside part like so. That I can just clean up the end. So I'll clean up the end now. But first I will have to change that to the left-handed one again. Just clean it until I get it clean like this. That's enough. I need to burr it a little bit. Be careful when you do that. Let's turn it around. And I have to set a taper. Or maybe just file it, maybe. I can find a file. One moment. So I just finished the tip for the soldering iron. I'll not put it in. Some sleeve goes in there. And the iron itself just as the hole. I'll try that out. So here it is. Looks okay. So now I can solder again. Time will tell how quick this will get eaten away and dissolved in the solder. It's not the ideal material, but it will work. That's it for the soldering iron. And here I am again, and I hope that wasn't too shaky. I bumped the camera a few times. And yeah, that's it for me, and hopefully I will be able to do some casting on this thing. The first part I have to do it 2 times. It's too big for doing 2 parts with one crucible filled up. But yeah, we'll try to do 1, maybe even 2 castings tomorrow. That will be Sunday, and hopefully they fit together. Maybe I clean up the surface a little before I do that, because that surface is crucial for those 2 parts being able to fit together and to prevent flashing. But we will see. Just an experiment. I never did zinc die casting before, but it shouldn't be that complicated. So that's it for me. Thanks for watching, and I hope I will be able to upload a video in the next few days on that casting.